Hello everyone, and welcome to lesson 8.1, which is on the power of zero and negative exponents. So we're going to talk about two things in this section. The first thing that we're going to talk about is having the power of zero and what that means and what that does to problems. Then we're going to take a look at what happens when you have negative exponents and how to rewrite that to make answers more beneficial for us. So the first thing that we need to talk about is the exponent of zero. What we need to know is that anything raised to the zero power is automatically equal to 1. We don't have to calculate extra stuff. We don't have to do anything extra or special. As soon as we see something is raised to the zero power, you can just note that as being 1. No problems. We have 3 examples of that on the screen here. First, we have 20 raised to the zero power. So as soon as you see a number, whether that's a positive number, a negative number, a fraction, doesn't matter. If that's raised to the zero power, the total answer at the end is just 1. No thought needs to go into that. Another way that we can see things raised to the zero power is when you have something in parentheses raised to the zero power. Now what that means is that all this stuff that I'm highlighting, the x and the y, everything inside that parentheses is raised to the zero power. Sometimes you will see this in a lot of different formats. You'll see things that you can simplify, things that you can reduce, things that you can actually do math on. But if all of that stuff is inside a parenthesis and the entire parenthesis is raised to the zero power, then the answer is automatically 1. It doesn't matter if you can do stuff, simplify, or not. Sometimes we'll get caught up in it and we'll miss the zero power, but just know, no matter how complicated, no matter how much stuff is in there, if it's inside a parenthesis and the entire parenthesis is raised to the zero power, the answer is automatically 1. And then in our third example, we have a good term here, 310 x squared y to the 0. So in this case, the only thing raised to the zero power is y. And I highlighted that y. So what ends up happening in this problem here is that the y to the zero power ends up being equal to 1, and that just leaves me with the 310x squared, which you see why that is the case. So the zero power can work to our advantage to help us simplify things and reduce things quickly as long as we recognize it. We'll see some examples of that in a little bit. The next thing that we need to talk about here are negative exponents. Now, negative exponents happen in fractions or in math sometimes, and they're okay. The biggest thing that we need to understand is how to deal with negative exponents. So, the first thing to say, which is written in blue, is negative exponents can be written as is, so we can leave it as it is, or we can write it as a fraction. So when we are writing things as a fraction, we can say 1 over, and I'm going to do this in both at the same time. All right, so when we want to write things as a fraction, we will start it as 1 over, and then all we have to do is take the variable and then whatever the exponent is without the negative sign. So in the first example, it's y and 4. In the second example, it's 8 and 3. And all we do is we write that in our denominator. So y to the 4th, 8 to the 3rd. And notice that right here, everything became positive when we wrote it as a denominator. So we could leave the negative exponent as is because in some problems it's just easier to simplify when we have negatives. Or if we need to rewrite answers using only positive exponents, then all we have to do is take a negative exponent and put it on the bottom of a fraction. We're going to see some examples of that on the next screen. But this is how we take negative exponents and rewrite them as fractions. Okay, so now we're going to take a look at how to multiply and divide terms with exponents. So if we are multiplying two terms that have exponents, all we're going to do is keep the same variable and add the exponents. If we are dividing two terms that have exponents, then we're going to keep the variable and subtract the exponents. So with multiplying, we add exponents. In division, we subtract exponents. So let's just go ahead and take a look at two examples of how that works. Our first example here is dealing with multiplication. So we have x to the fourth times everything in parentheses, which is x to the third minus 3x to the negative third. Now, we have a lot going on here, but we can handle it as long as we just take things one step at a time. So the first thing that we're going to look at is doing our distributive property, and that's going to be x to the fourth times x to the third. So by following our rule, anytime we multiply these things, x to the fourth times x to the third, we end up keeping the variable and adding the exponents together, and that's going to give us x to the seventh. Then we know that we're going to subtract, and our next step whenever we subtract, let's use a different color just to be clear, is we have to multiply x to the fourth times 3x to the negative third. Well, when we simplify that, that's going to give us 3, because we take care of our numbers, 3. Then we keep our variable, and we add exponents, so 4 plus negative 3. And then we simplify that, which gives us 3x to the first power, right? But we know that we don't always keep that first power in there, and we have our final answer. So that's how that works. It's nothing more complicated than that. We just got to remember, keep the variable, add the exponents when multiplying. Now, anytime we're dealing with division, it's just the opposite. We're going to be subtracting exponents here. Whenever I do these problems, I really like to break it down. First, I take a look at whatever my coefficients are and those numbers out in front, and I look at those and I say, well, what's 16 divided by 2? Well, 16 divided by 2 is 8. Then from there, we move on to the green, or to our x's that I'm highlighting in green, and in that, we have x to the fourth over x squared. That's going to give me x to the negative 4 minus 2. Again, we're subtracting exponents here. And for our third piece, we have y to the third power, or y divided by y to the third power. I will say, remember that the y that we have is going to be y to the first, even though it's not written. So that's y to the 1 minus 3. So all we did is we started at the top, we subtracted the bottom exponents, and now all we have to do to finish off the problem is simplify. So we end up with 8. Negative 4 minus 2 is negative 6. And 1 minus 3 is negative 2. Now, it is possible to leave your answer this way, and you will be fine. However, there are some problems that will ask you to express your answers with positive exponents only. That's when the rule that we talked about on the last screen, having something like x to the negative 6 being 1 over x to the 6th, is important. Because all we have to do is rewrite this answer that we've put in the box, x to the negative 6, y to the negative 2, as a fraction. So all we have to do is we create a fraction bar. We take our coefficient, whatever's in front, we put it on top, and then we take a look at our terms with negative exponents. And all we do is we take the terms with negative exponents and put them on the bottom using positive numbers. And that's it. So the coefficient goes on top, Everything with a negative exponent goes on the bottom. All right, so now what we're going to take a look at are 4 examples of everything that we've talked about today. Just kind of going through that, seeing how everything works, making sure that we understand what's going on. So the first thing that we have is 2 to the 3rd power, x to the 0 power, y to the 4th power, z to the 0 power. So we have all these terms, all these variables with different powers. The first thing we have to notice is that anything to the 0 power is 1. So we can just cross those out because 1 times anything is just anything else. That leaves us with 2 to the 3rd times y to the 4th. And the thing that we have to pay attention to here is 2 to the 3rd power. We can simplify that, so that just becomes 8 y to the 4th. All right, moving on to number 2. We have 2x minus 3x plus 5x squared minus 1, all that raised to the 0 power. Now, I can look here and I can see that there's a lot of things that we could change, right? We can combine terms that I've highlighted in blue there. We can maybe move the 5x squared in the front and organize things a little better. But at the end of the day, everything's being raised to the 0 power. And I'm going to highlight these parentheses because everything inside the parentheses is raised to the 0 power. So it doesn't matter if we choose to simplify it or not. We can reorganize things, simplify things, combine things, do whatever we want, but at the end of the day, it's all raised to the 0 power, and if it's all raised to the 0 power, then the answer is 1. All right, moving on to number 3. Number 3 is another fraction. We have 2x to the 4th y squared divided by 5x to the negative 3rd y to the 5th. So we handled this just like we've done before. We start with looking at our coefficients. We have 2 over 5. Unfortunately, that does not simplify, so that just gives me a fraction, which is 2 in the numerator, 5 in the denominator. From here, we move on to our x's, and we remember with division, anytime we have x's, we subtract exponents, so that gives me 4 minus negative 3. And then finally, we move on to our y's, and again, we're subtracting exponents here with y's, and that's going to give me y to the 2 minus 5. As we simplify to get our answer, we end up getting 2/5 x to the 7th because 4 minus negative 3 is really just 4 plus 3, so that's 7. And then we get y to the 2 minus 5, so that's negative 3. All right, so we've gotten our answer, and like we mentioned before, it is possible to leave our answer this way sometimes. However, we know that sometimes we are going to have to rewrite things so we have only positive exponents. So to do that, we've got to create a fraction. And as we start going over the fraction, we look at our pieces, right? Our first piece that we look at is right here, the 2/5. Well, that's already in fraction form, so what's nice for us is we can just keep that. 2 on the top, 5 on the bottom. No changing. Okay, the next thing that we look at is x to the 7th. Well, x to the 7th is a positive exponent already, so there's no need to rewrite that or do anything special there. We just put that x to the 7th on top, and then we look at our final term, which is y to the negative 3. And as we've talked about, when we rewrite those as positive, we have to write our fraction, but they go on the bottom of our fraction. With a positive number. So if we needed to write this answer with all positive exponents, that's how we would do it. We keep the fraction the same, positive exponents go to the top, negative exponents go to the bottom. It's that simple. Okay, our last problem is a pretty big combination. I'm going to scroll up a little bit more just to give myself some more room here. And it's a combination of everything that we've talked about. Now, whenever we're looking at this, we look around, we see what we can do, we see what we can simplify, and we tackle it. So to simplify, we're going to start on our numerator, and we're going to take our numerator here, m squared, and we're just going to distribute. And we got to distribute it all the way out. What that does is that just simplifies everything, and as we do that, we end up getting m squared plus 2 minus m2 plus 1, because if we remember in our second term, there's really a 1 there. Cannot forget that. Always, always, always make sure to include that exponent there. And then in our last term, we have plus m2 minus 3. And then that's going to be divided by, on the bottom, we'll change colors, m, and we distribute the m on the bottom. So that gives me m1 plus 3 plus m1 minus 2 minus m1 plus 1. Okay, simplifying that out, we end up getting on the top m to the 4 minus m to the third plus m to the negative 1. In our denominator, we end up getting m to the 1 plus 3, which is m to the 4, plus m to the third minus m squared. All right, so now as we take care of this, we are in a spot where we are done. We can't combine anything, right? We can look for things that have the same exponents, right? And we can look at how that works, right? We have m to the 4th over m to the 4th. Those can cancel. All right, we have negative m to the 3rd over positive m to the 3rd. Those cancel, but actually really give me a negative 1 because the negative divided by a positive. And then at the end, we have m to the 1 over m squared. And those two things we can subtract. So that's going to be m to the negative 1 minus 2, which ends up being negative 1m to the negative 3. We can leave this as our answer, or if we need to simplify this problem, we can write it all as positive exponents. So the negative 1 goes on top, and the m to the 3 goes on bottom. And now you have everything with positive exponents. So that is how you handle those problems. Clearly the fourth problem has a little more complication to it because it's asking you to do both things at the same time. But if we noticed, we simplified the numerator, we simplified the denominator, then we started trying to cancel things out and simplifying things. That made life really easy for us to do it that way. And then as we got to our answer, it's kind of like everything else that we've done. We can either express our answer with the negative exponent, or we can rewrite it as a fraction and have all positive exponents. Hopefully this has helped you out with dealing with problems from section 8.1, how to deal with zero exponents, and how to rewrite and deal with negative exponents. But if you are still having problems, if you are still struggling, if you need more help, please don't hesitate, reach out to me and let me know.